Because we didn't put a key word in the video yesterday, we're not going to do it today. We didn't. Nevaeh doesn't deserve all the treats, right? What is she even doing today? Taking a nap, probably?
Student council
thing. She's not student council.
She's like making our school better.
Good joke. All right. So we have vertical parabolas and we have horizontal parabolas. Horizontal parabolas are of the form x equals. We have a times, and it would be y minus k quantity squared plus h. Okay? That is our horizontal parabola. Notice that the x and the y's change spot and the hk's change spots as well. The vertex is still located at hk. And what that means for us is that the horizontal shift is now on the outside and the vertical shift is on the inside paired with y. Our direction of opening, if A is positive, it opens to the right. If A is negative, it opens to the left. The length of the lattice rectum is still the absolute value for P. So I'm going to just sketch a gentle graph here. Not going to make it too crazy, just a basic graph of a parabola. And we say that that thing's the vertex right there at HK. And so the axis of symmetry, instead of being a vertical line this time, the axis of symmetry is a horizontal line. Do you remember, is a horizontal line x equals or y equals?
Y equals.
It is y equals. This time as it goes through the y value of the vertex, which is y equals k. The focus is located inside the parabola, and the directrix is located outside of the parabola, and they are both located p units away from the vertex. So if I'd like to write an expression for the location of the focus, I move p units from the vertex. Is that going to change the h value or the k value if I move it this way? The horizontal value, because I'm moving it horizontally. So change h. So I have h plus p and then k. And if I move it backwards, I have a vertical line for the directrix. A vertical line is of the form x equals, and it would be whatever h is minus p. And so there we have the layout. And again, Haley was not, you weren't here yesterday?
Not for most of class.
Oh, that's right. Okay. So I told the class that they get to use their own notes for this test. So you put it together yourself. If you want to use this sheet on the back, you can. What I want you to understand is that we go through these problems today, you want to be thinking about what would you need to have written down in order to help you out. So if you like some of that stuff, then you go ahead and write that down on your sheet. But if you'd like it in a different way, then go ahead. So I'm going to clear this information here. We're going to redo these 3 problems and call it a day. The first one, so we did this one yesterday. And so now we're going to do that guy. We are going to label the direction, the vertex, the axis of symmetry, the focus, the directrix, and the length of the lattice rectum. What I want you to do first is quietly talk to the person next to you and decide, do you think that this parabola opens up, down, right, or left? And why do you think that? Go ahead, talk quietly.
Sure.
That was heard me from watching those. Do you know what we're doing?
There's no homework yesterday, right?
No.
You said which one? Oh, looks like hers.
Okay, so I hope that you were able to see that because it's y squared, this is going to be a horizontal parabola. And so because the y is being squared, I want to solve for x. If I divide both sides by 2, I get x is equal to 1/2 y squared. This is a horizontal parabola, and the direction is opening to the right. Notice compared to this problem back here, this was an x plus 2 squared and then a plus 3 on the end. That shifted our vertex. There's no shift like that, so therefore what is the vertex? This is a 0, 0 problem. And so at this point, I don't like to fill out all 6 of these. I like to go ahead and just make an axis, an x and y axis, and start to generate my graph. I go ahead and I plot that 0, 0. And the axis of symmetry will go with the direction of opening. And so I've now named my axis of symmetry to be y is equal to 0. And those are all things that are reviewed from previous years. Okay? Except for talking about, the horizontal piece compared to the vertical piece. In order to find the focus of the directrix and the length of the lattice rectum, I have to be able to find P. Do you remember the equation to find P? Yeah, A is 1 over 4P, and our A value is 1/2. So you have 1 over 2 is equal to 1 over 4P. Now, sometimes people can just look at that and see what P is. If you can't, then you go ahead and cross multiply. 4P is equal to 2. Divide by 4, and P is 1/2. So I use that 1/2 to be able to determine everything else. Now, I know my friend Maggie is thinking to herself right now, Mr. Gans, you put this axis here, but you didn't go ahead and put any tick marks on it. I like to wait until I get the length of the lattice rectum before I go ahead and make all my tick marks, because I don't know how big to make it. The lattice rectum is going to be 4 times that value, so it's 2. So if the length of the lattice rectum is 2, does everybody agree that if I made like a 3 by 3 graph, that would be plenty? So I'm just going to make a 3 by 3 graph. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, that's going to be plenty big. The focus and the directrix, these are located P units from the vertex. So I move over a 1/2 unit, and that's my focus. Somebody name that coordinate for me. Not everybody at once. 1/2 0. And then everybody says, oh, this is good. I like that. Thanks. And then I move the other direction, a 1/2 of a unit, and I draw a line, a vertical line, that has the equation of x is equal to -1/2. And I almost have all the information I need to draw this graph. The last thing I need is to span my lattice rectum. It is the length of 2, so I'm going to go 1 unit up and 1 unit down. I move 1 unit up and I move 1 unit down, and I have this spanning right there. That's going to allow me to generate the shape of my parabola. And I'm ready to be judged. Bryant has offered to judge me today. Thank you, Bryant. We'll see what we get here. A true parabola is one whose coordinates are the same distance from the directrix as they are from the focus. And so I've got that, and I've got this. And the question is, are those the same length? I will go ahead and I will take this and I'll spin it and I'll bring it on up to the other one, and we'll see how close I got.
Golly, I'll give you a solid 9.2.
Ah!
It's real perfect, except for it's a little long on one side. 9.7.
Okay, all right.
9.7.
I'll take the 9.7. I'll take 9.7.
You'll get 10 out of 10.
Earlier, Claire Thompson, she gave me a 9 today first. I thought I'd done really, really good. And then the next one, I thought I nailed it. I was like, this is probably the best parabola I've ever drawn in my life. She gave me a 9.5. She's a tough grader. And then my last one was off by like a 7. Maybe she dropped me down to like a 6. But anyway, that's all right. Claire's a harsh grader. All right, I respect your 9.7. Very good. That's pretty close, though, is it? Yeah, let's go. All right, we'll try another one. I got 4x squared plus 7y is equal to 0. Talk quietly with the person next to you. Which way do you think it opens? Up, down, right, or left?
I think it's going to be opposite because the x is squared.
Okay, this is a vertical parabola, and it goes down. Because it's a vertical parabola, we know it's vertical because the x is being squared. That means we need to solve for y. So if I subtract the 4x squared, I get 7y is equal to negative 4x squared. Then I divide by 7, and I get y is equal to negative 4 over 7 times x squared. So this is a vertical parabola, and it is a negative 4 over 7, so it goes down. Are there any questions about how I know what to solve for? Okay, we have our direction. We have our vertex. We have our axis of symmetry. We have our focus, our directrix, and the length of our lattice rectum. Direction we've already established is down. The vertex is located at 0, 0. I go ahead and I draw my grid, my coordinate plane. Sorry for all those math people who are watching. I said grid. This is not a very mathematical term. The coordinate plane. I will plot my vertex. And then I'm going to draw my axis of symmetry. What's the equation for the axis of symmetry? X equals 0. Good. For these next three, I have to find what value? P. And I use my equation, which is A, negative 4 over 7 is equal to 1 over 4P. I cross multiply, and I get negative 16P is equal to 7. I divide by negative 16. And we encounter what most of you thought would happen at the very beginning, which is we have this kind of ugly number to deal with. Okay, Haley's making a face at the number right now, okay? I feel a little uncomfortable here. It's, I don't mind, it reminds me of a wrench, you know, like 7/16 wrench, you know what I mean? It's like, you know, I like to do a little card work from time to time. But yeah, it's a little bit awkward of a number. I'm going to use that to find the length of the lattice rectum right now so I can figure out what kind of scale to make this. The lattice rectum is going to be the absolute value of 4 over 1 times negative 7 over 16. And notice that when I multiply that, the 4 over 16 reduces to a 1 over 4. And so we get the length of the lattice rectum is simply going to be 7/4. Now, if you were to estimate 7/4, 7/4 is about what?
1 3/4.
Yeah, it's exactly 1 3/4. It's about 2 though, right? So if the length of our lattice rectum is 2, would everybody agree if I made a 3x3 graph again, that would be more than plenty? So I'm just going to take this graph, I'm going to make a 3x3 graph. That will be more than plenty. Cool, and the p-value, as we encountered, p was equal to negative 7 over 16. So because the p-value is negative, it means that instead of going up, I'm going to move down. So 7/16 is almost a half, so I'm going to move down about a half unit. What's that location for my focus?
0, negative 7/16.
Good. And the directrix will be a line that will be up there in the opposite direction. And that equation is y is equal to 7 over 16. What is the last thing I need to do to draw my graph? span the lattice rectum, right? Now, if you look, the length of the lattice rectum is 7/4. So I'm going to go half of that in each direction. What's half of 7/4? Or as Ty said, half of 1 3/4? 7/8. Half of 7/4 is 7/8. Everybody agree? Which is just a little bit less than 1. So I'll go just a little bit less than 1 to the left and a little bit less than 1 to the right. I actually did that opposite, but that's fine. I'll put some dots on the end and go ahead and try to draw my perfect parabola. And we'll see how perfect it is. Max is laughing right now. He thinks I'm way off. Well, you try it, Max. We'll see how close you are. Is yours not very good? All right, so I plotted that, and now we're going to grab that. I'm going to twist and turn it, and I'm going to bring it up here, and we're going to let Bryant, again, be...
This might be your 10 out of 10.
Can you like scooch it over so it's not on the black line, so we can see it?
Yeah, let's get it more on the, both of them on the white.
Can you like zoom?
What do you mean?
Make it bigger.
Make it,
Like,
pull
move
it down,
to
pull
the
them
side.
both
Over
down
the
to
side.
this little white
They'll put it in
portion.
the white section
So we
see.
can see without.
That one too?
Yes. Gosh, I wish these were straighter lines.
Okay, now tap out of the.
Oh, booyah! There's the 10 out of 10.
Yeah, I told you one. I told you. He was talking crap about me. No, my parabolas suck. Take that, buddy. I knew I could do it.
Pretty solid stuff.
Oh, got to find a way to have fun with it, right? Got to find a way to have fun with it. Very good. I got a 10 out of 10. Thank you, Brian. I'm convinced that Claire Edwards would not have given me a 10 out of 10. But that's all right. Claire is her own person, and I respect her for that. High standards.
Is it not Thompson?
Yeah, it's Thompson.
What's that?
Is it her last name Thompson?
Is it What did I say?
Edwards?
Claire Edwards. That's a character from Andy Griffith. Anybody watch the Andy Griffith show? We watched the Andy Griffith show. Claire Edwards. She's the friend of Vampy. I've done that like 4 times, and I've caught myself every time except for this time. So just like I want to say Claire, I'm gonna say Edwards. I'm like Thompson. It's not Claire Edwards. Just want to do a 12. Go ahead and try to figure out with your friend next to you, up, down, right, or left, and why.
This is going to be.
The y is going to be square.
So it's so it's going to be a sideways one.
Yeah.
But I think it's still going to go to the right but it's going to start at 2 that way.
Okay, this is a horizontal one. It's going to go to the right. If I subtract the 12, I get 12x is equal to y minus 2 y squared minus 12. And then we divide by 12. And I get x is equal to, instead of dividing by 12, I'm going to write 1/12 times y minus 2 y squared minus 1. You can see that the x equals makes it horizontal, and because the 1/12 is positive, it does in fact go to the right.
Where did you get the 12 from the other side?
So I got rid of the 1 because if it's a 1,
okay.
it doesn't work out very well,
Okay.
and so I always forget to change that in the notes, so we're making that 12. So sorry about that. Go direction. We're gonna go vertex, axis of symmetry, focus, directrix, and the length of the lattice rectum. Direction, you've already established that this opens to the right. Good job. Whisper to the person next to you, not loud enough for everybody else to hear. What do you believe is the vertex? -1, +2 is correct because the vertical shift is right here. It's paired with the y. Okay, so it's 2, and then the x is -1. It changes, folks, when it flips to x and y. So did anybody write 2, -1?
Yeah.
When the x and y's change, then these change too. Okay, this gets paired with the y.
Oh, you changed the one. No, in the very beginning.
Yeah, in the very beginning, I changed it from 1 to 12. Okay, garage door. Got to get that changed.
It's become part of the class.
All right. So I'm going to plot this, but first I want to figure out what scale I should make. So I'm going to find the length of my lattice rectum. This is actually pretty easy to do. We take 1 over 12 and set it equal to 1 over 4p. As you do that, what is the p value? P is 3, right? So we know that p is equal to 3. So that means that the length of our lattice rectum will actually be 12. So that's a pretty long, segment. So this graph is going to have to be a little bit bigger than the others. So I'm going to make like a 12 by 12 or a 10 by 10 graph to try to see everything. And I'm going to go by 2s. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And the vertex is located at -1, 2, so I'm going to plot that. I'm going to go back 1, and I'm going to go up 2. The axis of symmetry will divide this in half. It will be a horizontal line. What is the equation of that line? Good. Y is equal to 2. I have my lattice rectum. I need the focus and the directrix. We notice that the focus is located 3 units away from the vertex. So I move 3 units to the right. What's the location of my focus? 2, 2. And the directrix is 3 units in the opposite direction, and that is a vertical line. Go ahead and try to redo this. I want to try to get a better grade this time. Uh-oh. And so that will be the equation of x equals -4. So the last thing I do to finish this off is I'm going to stretch the length of my lattice rectum, or 12 units, so 6 units in each direction. So I'm going to go 6 units up, and I'm going to go 6 units down. And you can see that that's the width or the spanning of my parabola. Now, so far, this has been my worst attempt in all of my classes. It's been this last problem. I just haven't been able to get it right. Since Bryant gave me a 10 out of 10 on the last one, we're going to ask Maddie to grade me on this one. You up for it, Maddie? Okay, you get to score me out of 10. Whatever you want. No hard feelings, I promise. Okay, where should I put the point? This side or this side? You can even choose.
Down.
Okay, right about there? Okay, we're going to check. We're going to go. Oh, okay, I didn't like that drawing there. We're going to try. Okay, and then I'll do one more. Let's see how it fits.
It's too big.
Too big.
Yeah.
It's like a 7.
All right.
But they would give you a 6.
She's like that, isn't she?
Yeah.
Oh well. I tried my best. That's the best entertainment I can provide. I sure hope that you have an entertaining weekend. Though I hope you don't have too much fun. Remember to make good decisions this weekend. If we come back on Monday and we hear about a bunch of minor consumptions that happen, it will not be a good thing. So, Be safe, have fun. We'll see you on Monday.